In number 11 through 13, we're given the graph and we need to write the equation of the ellipse. So to write the equation of an ellipse, let's look back at what the equation of an ellipse looks like. We need to know, one, we need to know the center, HK, and two, we need to know what the distance is from the center to the side of the ellipse in both the x direction and the y direction. So let's look at this problem and see if we can determine those two things. So the center, HK, is 0, 0. And let's look at the distances here. So in the x direction, we have a distance of 3. And in the y direction, we have a distance of 1, 2, 3, 4, 5. So now let's see if we can plug these numbers into the equation of an ellipse. The h and the k are 0. So when we plug into x minus h squared or y minus k squared, right now I'm just going to put a question mark here, that just becomes x squared and y squared. And then we need to have a 1 on this side, so I'm going to put a 1. Now the denominator of the two fractions should be the distance from the center to the edge of the parabola, but squared. So in the x direction, that would go under the x squared. The distance here is 3. If we square that, that gives us 9. In the y direction, the distance is 5. If we square that, that gives us 25. So this is the equation of our ellipse. Let's also look at number 13. Number 13, the center is no longer at 0, 0. The center is at 1, negative 1. So that's the h and the k. So plugging into our ellipse equation, okay, we have x minus h squared, so x minus 1 squared. I'm going to need a denominator here. Okay, and then y minus k would give me y plus 1 squared, and then equals 1. Now the denominators, in the x direction from here to here, 1, 2, 3, 4, 5. And in the y direction from the center to the edge of the ellipse is 1, 2, 3. So under the x squared, we need to look at the distance in the x direction. So 5, but we need to square it, so that'll be 25. And in the y direction, 3 squared, which is 9.